All right, next we go over these 19 questions I have listed on the practice final for Calculus 3. So let's get going, and I will try to do a chunk at a time so you do not have to end up with a very long video for all 19 questions. All right, number one, you are to come up with an equation of the plane through -1, 3, 5, 0. And that's a point on the plane. That's a point on the plane, and then normal to or perpendicular to -3, 2, 1. How difficult is this problem? I hope you notice that this is an easy problem. All right, so you are given a normal vector right here. So those numbers are used as coefficients for the equation. -3, x minus -1. You can write as x plus 1, plus 2, y minus 3, plus 1, z minus 0. Of course, these numbers are coming from the coordinates of the point. And then make sure you write equal to 0, because if you don't have that, you don't even have an equation, right? And remember how this came about. You are to, basically pick any point x, y, z. Here's a point -1, 3, 0. So the idea is any vector from x, y, z on the plane to the given point -1, -1, 3, 0, or vice versa. I guess this is the starting point. This is the ending point. Has to be perpendicular to this normal vector n, right? That's the idea. And so the dot product, which is written as the left-hand side, must be equal to 0. All right, now this suffices. If you really want to go ahead and move on, you can write this as your answer and move on. I, as one who grades your test, would greatly appreciate it if you actually work this out. So you get this, right? -1, -3x. Oh, sorry, that's -3. So you can't talk and write at the same time. Well, I can't. Anyway, so if you do this, -3x plus 2y plus z, and then of course the other the constant terms will be combined to -9 equals 0. So this is what you have as your solution, and that would be nice. Now, some people don't like this leading negative sign. So if that's the case, that's fine. You can change the sign for each term, and you can get 3x minus 2y minus z plus 9 is equal to 0, and that would be a very nice answer. All right, now one thing you may want to do is to plug in -1, 3, 0 into this equation, because if this is the correct answer, clearly -1, 3, 0 should satisfy this equation, right? And so let's check quickly. 3 times -1 plus -2 times 3 minus 0 plus 9. Hopefully this is equal to 0 according to this equation. That's -3, -6 plus 9, and indeed it is 0. So that must be the correct answer. All right, let's go to number 2. To find the rate of change, here is the equation. Let me pause this so I can write this. Okay, so we have to find the directional derivative. It says the find of the rate of the change of the function in this direction. That's clearly a question on directional derivative, right? Notice here, though, v is not a unit vector. So you want to make sure that you normalize this first, right? So what is that? That's, of course, v divided by the norm of v, and that's going to be 1, -2 divided by what? 1 square plus 2 square, and that's, of course, the square root of 5. And so you want to use this when you are eventually going to take the dot product of this and the gradient. All right, and so let's find the gradient. Gradient is, all right, so you take the derivative of this with respect to x, that's 2x minus 5y squared, comma, and the -3 minus 5, 5 times 2 is 10, 10xy. You have to evaluate this, right, at this point P, which, the point is not, I didn't write that. It's 2, 3. Okay, so at 2, 3, this is how I denote that when I evaluate anything, the vertical line and then the point 2, 3. All right, so this is not a simple number, right? I don't know why I picked numbers like 2, 3. But anyway, 2 times 2, that's 4, minus 5 times 3 square, that's 9, comma, negative 3 minus 10 times 2 times 3. Let's do the arithmetic. That's 4 minus 45. That's negative 41. And then this is negative 3 minus 60. That's negative 63. Yuck, right? I hope you will not see these numbers on the real final, and that's not too bad. Right? Okay, so this is the gradient. And what is the directional derivative in the direction of u or direction of v? That is the dot product of these two things, right? And so that will be negative 41, negative 63, dotted with, well, let's see, dotted with the square root of 5 in the denominator, 1, negative 2. I'm the root of 5 in the denominator outside. All right, now you have negative 41 plus, okay, it's minus 63 times negative 2, and that's going to be plus 126. Still not very nice. Okay, so you have to do subtraction. That's 85 divided by the square root of 5. Okay, and that's a fine answer. Now, I know some of you, because you were trained so hard to rationalize the denominator, which is okay if you have to calculate this without a calculator or something for some ancient reasons, but you could do that, right? So this will be 5, and if you divide 85 by 5, you get 17, and so that's okay too, but you don't have to do that. This is a perfectly acceptable answer. You should not discriminate against radicals in the denominator. Okay, so that's number 2. Okay, let's go to number 3, which is this problem. We are to parameterize the segment from this point to this point. Okay, so how do you do that? Well, you should know how to describe or express a line, not the line segment, but a line going through these 2 points. All right, so x is negative 3. Oh, by the way, I have to do something else. Sorry, I should not do that. And I have to know the vector from this to this. That's one way to do that. So let's find the vector between, let's call this P0 and let's call this P1. Okay, you can call them anything you want, but so P1, no, sorry, P0, P1, this vector is, okay, 3 minus negative 3, that's 6, negative 2, and 3. All I do is subtract these corresponding coordinates, right? So 6, negative 2, positive 3 is the vector from P0 to P1. So the line, if you don't worry about the segment part, the parametric equations would be negative 3 plus 6t, while in this point, the P0 as the reference point or the starting point, 2 minus 2t, and then z is 1 plus 3t, right? Okay, and if you let t go from negative to positive infinity, then this will be covering the entire line. But as you can tell, if you restrict it to, well, when t is equal to 0, of course, you get the first point. When t is 1, the way I wrote this, when t is equal to 1, you get exactly the second point, right? I mean, so for instance, when t is equal to 1 here for x, negative 3 plus 6, which is 3. Y is 2 minus 2, that's 0. And then z, 1, which is 4. Okay, so this together with these parametric equations will give you precisely what you need for the line segment between these 2 points. All right, cool. Let's go to number 4. we are to find an equation of the plane that is tangent to this surface, x squared plus 2xy minus y minus 1 is equal to the function, which is z, at 1, -2, -4. All right, so before you go into this question, though, you may want to check, is this a valid question? Like, how do I know that this point is actually on this plane, right? So this is, you don't have to do this step here, but I always check to see, because I'm an instructor, is this question a valid question? Is this point on this plane? And I mean, on this function, right? So surface. And so you just try to plug in 1 and -2 for x and y respectively. You get 1 square plus 2, 1, -2 minus 1. I hope it's -4, right? It's 1 minus 4 minus 1. And clearly that's -4. So indeed, this is a good question. It's a question where you are to find the tangent plane, which is, plane tangent to this surface. It's a curved surface at 1, -2, -4. All right, so you want to do fx and fy. Basically, you're taking the gradient of this. That's 2x plus 2y for the the first partial, and then the partial with respect to y is, well, let's see, that's 2x, right? And so then you evaluate this at 1, -2, each of these. Right? So then you get 2 minus 4, it's -2 for the first number, and then 2 for the second number. So this means that the normal vector is -2, 2. And do you remember the last one here? You may want to go back and review that little lesson where we found how to write the equation of a line tangent to a plane. The last one that you have to insert is -1. Okay, and that has to do with the fact that this is z, and so well, yeah, again, you may want to go back and see why this is -1 if you are if you do not remember that. Okay, but anyway, the last component will be -1. The first component is fx, the second one is fy. So these come from the gradient of the function. All right, now it should be easy because you have a point, you have a normal vector, so you can write down your equation of the tangent plane. That's -2 x minus 1 plus 2 x minus -2, that's plus 4, and then minus 1 times x, z, oh, sorry, that should be a y here. And then this is z minus -4, so that's plus 4. And is that it? Oh, of course not. You have to make sure to put 0 in here. And I think there is something wrong here, because instead of y minus -2, I put y minus -4. So that should be a 2, right? All right, so again, let's go back and make sure I get the point right. This tells me the x coordinate at the given point is 1. This tells me that the y coordinate should be -2. This says the z coordinate is -4. Okay, so that's it. Again, this is a perfectly acceptable answer, not the one I prefer, because it's harder to grade, but that's okay. If you try to work this out, you get -2x plus 2 plus 2y plus 4 minus z minus 4 is equal to 0. The 4s will cancel. -2x plus 2y minus z plus 2 is equal to 0. And that is a fine answer. If you don't like the leading negative sign, you can also switch all the signs. 2x minus 2y plus z minus 2 is equal to 0, and that's acceptable. Now, again, I would highly encourage you to check to make sure that that point is on this line, because if it's not, then your answer can't be right? I mean, your tangent plane at this point must be tangent at that, at that point. It has to be a part of that tangent plane. So if you plug in 1, here, -2 and -4, you should get, this equation should be satisfied. That's 2 plus 4 minus 4 minus 2. And of course, that is equal to 0, so that checks. So I'm confident that this is the correct answer, and we go on. All right, let's do one more, and then we will take a little break and go to the next part of the video. Number 5 has to do with the integral that expresses the length of the parametrized curve. All right, so let me just write down the parametrization. Now, in the problem, it's the expression uses I, J, and K. You probably know I don't like that very much. 2t minus 1. I mean, sometimes, problem is given that way, so you can't help it. But why use I, J, and K when you don't have to? So it's 2t minus I, t squared minus t, 3. That is your parametrization. Oh, and then you have to have the restriction here. T goes from 0 to 3, right? You don't have to know what the curve looks like. And in fact, it's going to be pretty difficult to graph this, I think, right? But in order to find the length of the curve, all you have to do is really, let's just remember how you do this. Okay? You have the c, and you basically have to find the speed. That's the derivative of r, or the norm of the derivative of r, okay? And that's really what you have to do. In this case, you would have to put the upper and lower bounds, okay? This equation basically says that the distance is speed times time, something that you knew a long time ago, right? Okay, so I need to have the r prime and the derivative. I mean, the derivative of r, and then the magnitude of it, okay? So magnitude of r prime. So it's going to be 2, and then 2t minus 1, 0, right? Pretty simple. And so the magnitude of this, which depends on t, is the square root of 2 squared plus 2t minus 1 squared, right? So really, that's as much as I can do. All right, so the answer to this question is the integral from 0 to 3 of the square root of 4 plus 2t minus 1 quantity square and dt. This is a fine answer. The question says, write an integral that expresses the length of the curve. So I just did that. You don't really have to simplify this. But if you really want to, you can do the following. That's 4t squared minus 4t plus 1. Is that right? And you can combine. It's not much of a simplification. But if you want to, you can do 4t squared minus 4t plus 5, all under the radical dt. Good thing they did not ask you to evaluate this, because that's not so simple. All right, so let's take a break, and then we come back on part 2 of the solutions video. And we will start with number 6.